All right, so 10-2, geometry. We're going to talk about the measuring of angles and arcs in a circle. Okay, and the first thing we need to know is what a central angle is. A central angle is an angle whose vertex is at the center of the circle and whose sides are radii. Okay, so in this circle, and I'm going to use some colors if you like to do that. Angle GEF is a central angle. Okay, so an angle again is formed by the two radii, EG and EF. That forms angle GEF, which is between here and here. That opening is the angle. That is a central angle. Now, there's other central angles in this picture. We got angle CEF is a central angle, angle CEH is a central angle, angle HEG is a central angle. And what do you think all these angles add up to? 360. Good guess. They do. They add up to 360. Might as well go right there to that point. All these angles that I just mentioned, angle HEC, angle CEF, angle FEG, and angle GEH add up to 360. Okay, so we talked about the fact that those 5 angles would add up to 360 degrees, or actually 4. 1, 2, 3, 4. A central angle separates a circle into 2 arcs. Okay, so this is one arc, and the other arc would be the rest of the circle. Okay, so what we call the small arc is a minor arc, and the other one we call a major arc. Okay, so what's the difference? A minor arc is less than 180. A major arc is bigger than 180. And we'll talk about that some more. So, GF is a minor arc. I highlighted that in red. CHG is a major arc. C to H to G. That right there is a major arc because it's more than half of a circle. Okay, so I got a minor arc less than 180 and a major arc greater than 180. Central angles are inside with a vertex at the center. Some of the measures of the central angles of a circle with no interior points in common, meaning none of these angles have interior points in common, they're not overlapping. We would just add 4 angles up to get 360. The measure of a minor arc is less than 180 and equal to the measure of its central angle. So in this diagram, arc CF is equal to the measure of angle CEF. Okay, now if the measure of angle GEF is 80, so they're telling us if this was 80, then we would know the measure of what arc is 80, and it would be arc GF. So arc GF, its measure, M in front of there, the measure of arc GF equals 80 degrees. And that was just another example. Arc CF would be equal to whatever angle CEF is, and I don't know what that is. I'm not going to make something up. Good? The measure of a major arc is 360 minus the measure of the minor arc that's related to it. So in this picture, if you have the measure of angle CGF and you wanted to know what it was, arc C through G to F, that is, you have to go in that direction. So the second letter tells you which way to go. So you go from C. You don't go through the G this way because you would have rammed into the F already. All right, and F's got to be last. So how I know which way to go is I start with C, the next letter is G, and the last letter is F. So I can't go past F before I hit G. So I have to go from C to G to F. Now, the way you would get that angle measure is you take 360 minus this arc. the CF arc, which is what would be left. Now we're going to do this example. If the measure of angle GEF is 80, which you already have drawn on your picture, and you have arc GF, that measure is 80 degrees. So if you wanted to find the major arc related to that arc, it would be arc F. You could say C and then G. Arc F, CG. Oops, I wrote the G before I wrote the C. Not supposed to do that. FCG, that would equal 360 minus 80, which would be 280 degrees. Okay, you with me? So what you do to find, if you know this one arc, you can get the rest of the circle by doing 360 minus that angle. Okay? Two minor arcs are congruent if and only their corresponding central angles are congruent. All that is saying is that if the arc CF was congruent to FG, then this would have to be 80 degrees as well if that one was 80. That's all that's saying. Those central angles would have to be equal. Another arc addition postulate. Now let's think back. We've had the segment addition postulate and the angle addition postulate. Segment addition postulate said if you took two segments and put them together, you got a bigger one. Angle addition postulate said if you added two angles together, you got a bigger angle. So the arc addition postulate says if two arcs are next to one another and they share a common endpoint, just like a segment next to a segment, an angle with a shared side with another angle with a shared side. If you see how the F is in the middle, okay, kind of, you got arc CF plus the measure of arc FG would equal the measure of arc C to G. So you just put two arcs together. That's it. If I look at the picture, you got arc CF, arc FG. If you put them together, you're going to get arc C to G. That's all it's saying, adding arcs. Nothing that's earth-shattering. Okay, now the measure of a semicircle has half of a circle, so it's 180 degrees. So a semicircle is half of a circle. In the circle with center O below, the arc BAE is a semicircle, so the measure is 180. Now I'll get to that picture right now. BAE, I'm going to highlight that. That is 180 degrees, and the arc BAE, which is 180 degrees, is half a circle, or is a semicircle. And it's the bottom half. So you actually have two halves to your circle, so you have to use 3 letters to name it, so you know what half you're talking about. That's what this is about here, about practice naming arcs. You name a major arc with 3 points, and you go around the circle in the order of the points. So for example, if I wanted to name a major arc on this diagram, I could start, say, with E, go through E to A. And I have gone more than 180. So this arc, PEA, is a major arc. Right, so that's just an example of a major arc in that diagram. There's many of them that we could name. I just thought that one was an easy one to show. You usually name a minor arc with 2 points, and order does not matter. So if 3 points are used, order does matter. So example, we could call arc BD, or the same arc could be called arc BCD. But you don't have to use those 3 letters, because if you're going to give 2 letters, you have to go the shortest direction to get there. Okay? BD would be the same as BCD, because you have to follow the order of the letters. You name a semicircle with 3 points, and they tell you which half of the circle you mean. For example, we already named arc BAE was 180, and it was the bottom half semicircle. Let's name the other side. So if we want the other semicircle, arc BDE would be the top half. That hopefully makes sense. Okay, so the top half, I said BDE. Is there another way we could have named it that would have been the same thing? Would represent the same arc or the same half? Did I have to use D? BDE? It would have been okay to do BCE, all right? You 1 point on the way. So BCE would represent the top half just like this would. All right, but you only need 3 letters. Don't give 4. That's all. All right, now we're going to talk on the next page. So let's get to the next page and do some examples of how to find all these measurements. Okay, this should be the 3rd page in your ISM. If you want to label them. This was page 2. Okay, arc length. Oh, I don't want that yet. I want this first. Measuring angles and arcs continued. Arc measure means you were measuring in degrees. Arc measure is just the same as the central angle measure. So in this diagram, it says that segment BD and segment AC are diameters of the circle with center O. So BD is a diameter, and so is AC. It says identify each arc as a major arc, minor arc, or a semicircle. So we got to tell what these all are and find its measure. So we're going to have 2 answers to each problem. Okay, 2 answers each. Oops, because I've had this on a question similar to this on a quiz or test, and then I'll get one of the answers because people don't read carefully, and it wants 2 answers. It wants what type of arc it is, and it wants the measure. So if I go find BA, arc BA, it's a minor arc. So I'm going to write minor, and then comma, and then I'm going to write how big it is. Its measure would be the same as that angle, 44 degrees. Okay, number 2 is asking me for arc ACB. Now, it might be a major arc, or it might be half a circle, because it can be a semicircle named 3 letters, or a major arc named 3 letters. And we got to look. You can't just assume. So I go A, I got to go to C next, and then to B. So I can't go that way because I'll hit the B first. So I got to go A through C all the way to B. And that is a big one. So that is a major arc. All right, so I just write major, and now I'm going to figure out the size of it. I know that it's everything except, okay, so it went through C from A all the way to B. It's everything except the 44. So to figure this arc out, I'm going to do 360 minus 44. This is 44 out here. I can put that there. 360 minus 44 is going to give me the answer 316, right? All right. Arc BC is a minor arc because it's less than 180. I need to figure it out. Anybody have a strategy on how we could figure out arc BC? We need to know this angle. Cadence? Oh, yeah, you could do that. There's a little bit quicker way, though. Nothing wrong with your way. It would work. You see how this is half of a circle? So what's the next other way? There you go, 180 minus 44. Okay, so I don't care which way, but your other way works just fine. You're actually knowing pretty much about all of the angles when you go thinking like you were thinking. So 180 minus 44, 136. Good. All right, I'm going to go ahead and write that on my picture. I don't like the circle there. I'm going to put a 136 there because it might help us with other stuff. Now remember, that angle is also equal to the arc outside there. Okay, those are the same measure. All right, next I'm asked for arc BCD. Well, arc BCD is intercepting an entire diameter. BD is a diameter. So B to C to D is actually half of a circle. So this would be a semicircle. Okay, and a semicircle is always, yep, 180. Arc CD. All right, now I'm down here at the bottom. How come it's 44? It's minor and it's 44. What do we call this angle with this angle right here? Above, one's across from the other. Remember the word, it's actually the shape of this letter. Yeah, vertical. Okay, those are vertical angles. And then AD is vertical with the 136. So actually this would be 136, and it's a minor arc. All right. Got all those done. So these aren't that bad to figure out. Just a little number puzzle, and all we had to start with was one angle, but we also knew that these were diameters. That was real important. All right, now we're going to talk about arc length. Now this is different than arc measure. Arc measure has to do with the central angle. This measure of that arc is equal to the central angle. But now I want to figure out how actually long this is. Meaning how many inches long, how many feet long, whatever the units are. Right? An arc is part of a circle, and its length is part of the circumference of the circle. So before I even explain this formula, think about it. The circumference of a circle is pi times the diameter. We talked about that yesterday. An arc is only part of the circumference. So the length is the measure of the arc in degrees out of how many degrees in a whole circle? 360. That's why it's going to be that degree measure out of 360, because that tells you the part of the circle that you want. And then you multiply that times the circumference of the circle, and that'll give you a piece of that circumference. So arc length formula can be written two ways, with the radius or the diameter. I prefer we use the diameter one, because every time I have a diagram, if I'm given the radius, I know if the radius is r, then the diameter will be 2 times r. So all I have to do is multiply by 2. It's not that hard to do. Here's the formula for the length of that chunk of the circumference. It's the angle measure divided by 360 times the circumference, pi times the diameter. So let's do one. Round to the nearest hundredth. First, I want to know what's the diameter of this circle. So I go over here and I see RB, and it's a radius, and it equals 8 inches. So what's the diameter? It'd be 2 times 8, or 16 inches. So that's what I want right there. 16 inches for my diameter. Now I'm ready to find the length of arc AB. I take the angle 135. I want to find this arc length now. So that length will be the angle measure 135 divided by 360 times pi times the diameter, which we determined is 16. That's the length of that arc. We grab the calculator. We start typing 135. This is where you get your physical memory, guys, is practicing this part. 135 divided by 360. Typing it in helps. Times pi, second button and that arrow up. And I forgot though, the radius was the diameter was 16. That goes next. Now, rounding skills need to be worked on. 18.849555, blah, blah, blah. All right, it asked us to go to 2 decimal places. It says the hundredths, right? That's 2 decimal places. I've been getting people writing 19. That's not the answer to 2 decimal places. It's 18.8, and then you got to look at the 4, and you see it's a 4, but then you have to look at the number after it, and that's bigger than 5 or larger, so you round up. This would be 18.85 to the nearest hundredth. 18.85, and this was all in inches. That is the solution to the nearest hundredth. Hundredth place again, 0.00. You want to go 2 decimal places. All right, now I'm going to find the length of arc CB. Arc CB, I got to figure out that angle measure. Well, AC is a diameter, so I'm going to just go 180 minus 135, and that's going to be 45 degrees. So now I'm going to do 45 out of 360 times pi times 16 to find that length. So type away. 45 divided by 360. Type on your calculator. Times your pi and times 16. Got 6.28. Drop the decimal part off after the 8. And that's also in inches. Okay, number 9, use the circle with center O to find the length of arc DEA. Arc DEA from D through E all the way to A. I need to figure out that measure. It would be 120 plus, the box indicates 90. So that measurement is 210 degrees. So the length of DEA, we're going to do now 210 divided by 360 times pi. But wait, what's the diameter? Yep, gives D is 7. Okay, times 7. So typing 210 divided by 360 times your pi times 7. 12.8. What are we going to round that to? 12.8, and then round the 2 up to a 3. 8.3. The answer is 12.83 inches. Okay, that is the end of the ISN. So let's jump over to the packet, please. This just reiterates the definitions. A central angle is an angle whose vertex is the center of the circle. Central angle labeled here. I will go ahead and just follow the colors that are up here. If you want to highlight things on your picture, that's up to you. That is the opening of the central angle. Oh, the minor arc, they did in, let's do a major and a minor arc. A central angle separates the circle into 2 arcs, a major one and a minor one. The minor arc is GF, right here. And CHC C to H to G is a major arc. Let's do that in blue. It doesn't mean it's related to the one I already marked. It just happens to be a major arc. It's an example of a major arc. Okay. Enough of that. We already discussed all these properties and have them in our ISN. And go straight to examples. If AC is the diameter of the circle with center R, then we're going to find the measure of arc AB and the measure of arc ACB. So first let's do AB. So we're going to, you've got a little blank for that, right? You got blanks for both of those. Okay, to find the measure of arc AB, it's 42 degrees. It's just the measure. It's not the, you're not being asked for the length. The measure of arc ACB would be 360 minus 42. So that's 318 degrees. You good? Okay, number 2. Find the value of x. What we need to remember is all of the central angles in a circle add up to 360. So you could set up an equation or you could just start subtracting. What do you think you would do? Subtract? Okay, so you would say that x is equal to 360 and then start subtracting out the angles. And it doesn't matter what order you subtract them. But that's what you need to do. I mean, that's one way to start it off. So we just type away. Was the last one was 115? So did you get 80? Okay, so x is 80 degrees. Pardon me. I thought I'd write an equation on this one. X plus 90 plus 120 is 360. I mean, that's just another way to set it up. It's the same thing that we were just doing. You can just start subtracting from 360. If you chose to simplify this and do it algebraically, the x plus 210 equals 360, and then you'd subtract 210, and you would get, but you can just add up the ones you're given and then subtract from 360. Regardless of which way you do it, you should be getting 150 degrees for x. Oof, spit it out. Okay, number 4, find arc DC. Okay, I would like to see if maybe you guys could give me a strategy for finding that. How would you figure out that little angle? We need to know this angle right here. Are you ahead of me? That's what I'm wondering. Because I just see people busy. Okay, if you're busy and you're just figuring it all out on your own, make sure you're checking. How did you find this little angle? BE is a diameter, so that's half a circle. So you hopefully did 180 minus 45 minus 120. Yes? All right, arc DC, you should be getting 15 degrees, right? Okay, some of you are ahead of me. Some of you, I don't know where you are. Well, I hope you're paying attention and checking your answers. That's great if you get it. Now I need to know B, A, D. All right, that's all the way from B through A, all the way up to D. Well, I found out CD's 15, so if I put those together, this whole thing out here from D to B is 60. And then I need everything but that for BAD, so it's going to be 360 minus 60. So it should be 300 degrees. Okay, A, B, C. 90 plus 45 should be 135. Questions about those? Good. All right, no questions, then we'll move on to more arc length. Got more, the same formula over again, a central angle measure divided by 360 times pi times the diameter. This is the one I want to use. Use the circle with center P to find the length of each arc and round the answer to the nearest hundredth. I got arc RT. It's telling me that MP is 7 yards. I have to check and see that MT is a diameter. Okay, so the diameter is 7, so I'm ready to go. I got the measure of the angle 50, so I calculate 50 out of 360 times pi times 7. Don't know why my pi came out weird. There we go. I hope everybody's calculating and pushing those buttons because that's going to make you remember. Oh, it's only 3.05. That is not 3.5. I've had people rounding and all of a sudden putting a hundredths place into the ones place, tenths place. You can't do that. Like saying $3.05 is the same as $3.50. It's not. Okay, 3.05. Labeled yards. Okay, now they changed the whole problem for MS. It's no longer a radius or diameter of 7 as the last problem. I want to find arc M to S, so I need to know the measure of that angle. If that's 50 and MT is a diameter, then this would be 180 minus 50, 130. So we take 130 out of 360 times pi, and then I got to say, well, what did they give me? PR is 13. What is PR? PR is a radius, not a diameter. Since PR is 13, what is the diameter? Guys, 2 times 13, you got to have 26 for the number you put in here. If you put in 13, you got it wrong. Okay, it's got to be the diameter, unless you did the 2 pi r part. I'm just wanting you to find the diameter and plug it in. So 130 out of 360 times pi times 26. You should have had 29 point. Oh, how do you round that? I've been discussing that one today. If you got 496, you are supposed to go to the hundredths place. Behind the 9 is a 6, which means you have to round the 9 up. If you round 9 up, it goes to 10, which will increase the 4 to be a 5, and then you'll need a 0 in that spot. So it's 29.50. And that's in feet. Okay, 10. Find the length of each arc. So we got to make sure we're reading the directions. Is this on the next page? Thank you. Okay, arc DE. We want to find the length of that. We got a central angle of 120, so we'll start with 120 out of 360 times pi. Now I need times the diameter. It says the radius is 2. So that means the diameter is 4. Plug in 4. Type your 120 out of 360 times pi times 4. 4.19. No, that doesn't round to 4.2. You're not supposed to be rounding to the tenths. You're supposed to be rounding to the hundredths. So it'd be 4.19. The 8 after the first 8 rounds off the 8 to a 9. And that's in meters. All right, arc DEA, if the diameter is 7, find out the measure of the angle. D to E to A would be 120 plus 90. Gives me 210 out of 360 times pi times 7. All right, I got 12.83. And that would be in inches. Okay. 11. Find the length of each arc. Oh, I feel like I've done enough examples of this, but arc BC got an angle of 45 degrees out of 360 times pi. And then I check BE is a diameter. So diameter is 24. We pop in 24 into the formula. Okay, and I got 9.42. And that would be in feet. Uh-oh, did I round it wrong? No. No, you do not double round. Okay, so let's talk about that. I've had a lot of people doing that kind of thing, and I've been wondering what's going on. If you're going to go to the hundredths place where the 2 is, the only number you look at is the one behind it. That number is a 4. Therefore, you round down and you drop all of that decimal off. So 9.42 is the answer to the nearest hundredth. Now, I see what you're thinking. Some people are thinking, well, why wouldn't the 7 make that a 5 and then that 5 would make that a 3? Well, you're doing it twice. You're not rounding to the correct place. If you want to round to the nearest thousandth, which would be here, and then you would look at the 7 and you'd round the 4 up to a 5. So that would be 9.425 to the thousandth place. But if you're only going to the hundredth place, you do not look at those numbers and round them. Okay, you only go for what's behind the place you want to go to. All right, I hope that clarifies that. I've been wondering why we're having struggles with rounding. All right, let's finish up the last couple of problems. CBA, that would be 45 plus 90, so 135 out of 360 times pi. And then D to O is not a diameter, it's a radius. So that means the diameter would be 2 times 3, which is 6. So you need to put 6 into your formula. Okay, that's 7.07. Is that what you guys got? 7.07? Did I type that right? Millimeters. Okay, now I want to talk about the pie problem. Yolanda divided a circular apple pie. It's not anywhere close to time to go. Quit your packing up. Yolanda has divided a circular apple pie into 4 slices. Now, I gotta tell you, you might not want Yolanda cutting your pie when we find out how big these angles are. She cuts it with 4 radii. Normally, wouldn't you take a pie and go? Now, most of us would try to do, if you wanted to cut it evenly, wouldn't you probably try to go down that way and then that way? Well, look, Yolanda didn't do that. So if you had sharing pizza or pie with her, you might not be happy. So let's see, or you might like it better because you got the big one. Let's find out how big these are. So we got, these are the angle measures in degrees. What do the angles add up to? All of the angles of a circle would add up to 360. So I got to add all this up to 360. So let's add up our x's. We could have done that from the beginning. We got 9 plus 4, that'd be 13, plus another 5 would be 18x. And then the minus 10 and plus 10 cancel one another out. So we have 18x equals 360. Well, now we need to divide by 18 and find x. I think it's just 20, right? All right, so now we're going to be able to figure out all the angle measures that Yolanda made. Plug in 20, 3 times 20. One of them is 60 degrees. 6 times 20 minus 10 is 120 minus 10, that's 110 degrees. 4 times 20 plus 10 is 80 plus 10, which is 90 degrees. And 5 times 20 is 100 degrees. Now, if Yolanda cut her pie up evenly, what should all of those have been? 90 apiece. Then everybody is going to get the same size chunk of pie. If you got 4 people, let's say you really like pie, which one do you want to pick? Which piece? Yeah, the 110. That's going to make the biggest slice. Okay, and this guy's getting about half as much as that, almost. Yolanda's not a very good pie cutter. Okay, well, poor Yolanda. Anyway, this one's the average size, the size that would have been equal if we're all the same. Make sure you do your practice problems, and tomorrow we're going to answer some questions on the last section and this section.